Hey guys, welcome to my video tutorial. Today I'll be talking about similarity measures, and the similarity measures I will be talking about today is called cosine similarity measures. Now we have a plan of attack. What is our plan of attack? Our plan of attack is that I will do some explanation about the whole algorithm, how it works, what it entails, and also shows you the mathematical formula behind it. But what I won't be talking about is I won't be explaining the mathematics of how it works. I'll just be showing it to you. So if you want to know or learn more about the mathematical formula, you can check online, check other YouTube tutorials of how the mathematics works. But basically, the mathematics formula behind it is not something that is hard. I'm just going to explain the basics to you. So if you're okay with it, cool. If you are not, you check some other mathematical tutorial online. And also, the way this tutorial is going to be done is I'll be writing the code from my editor here and be running it. But if you don't want to go along the same process, we'll provide the full code, the full link of the code on GitHub. You can download them and practice it on your own or use it for whatever stuff you want to use it for. What is cosine similarity? So cosine similarity is an algorithm which is used to calculate the similarity of two vectors. And also, for it to work properly, you need to supply a non-null vectors to the functions. Also, cosine similarity works on two things, on two vectors. You can't supply one or three on the cosine similarity function, so you have to supply two iteratable vectors to the function. And also, it calculates the angle between two-dimensional vectors, between two n-dimensional vectors, but the vectors must be two. So you supply two n-dimensional vectors to the functions, so you get back the similarity scores. And also, you might want to get the angle at which both vectors are related. If you are not new to the field of data science, machine learning, similarity measure should not be something that is new or far-fetched to you. Other similarity measures are available, such as Euclidean distance and also Jackal similarity and all others. But today we'll be talking about cosine similarities. Now let me show you, this is the formula behind the cosine similarity. So the way it works is it will take the product of these and expand the formula into this. Like I said earlier, I won't be talking much about the mathematical formula. Most of my tutorials, or if not all my tutorials, will be based on strictly practicals. Then you do this, you write the code that perform these operations. Now straight to the result. Cosine similarity generates a matrix that says how related the two documents are by looking at the angle instead of magnitude. So I have three examples of an angle here, since cosine similarity deals with angle. The first one for similarity scores. The scores are in the same direction, so and they are between 0 degree. While the second one for unrelated scores are they are the same vectors, but the angle between them is near 90 degree. While for opposite score, the angle between them is 180 degree. So for the practical side, the language of choice that we'll be making use of is Python, and our code editor is Jupyter Notebook. Of course, we can use other ID, we can use VS Code, we can use Sublime. So far, you can type your code in then. Now let's head to the practical side. So what I'm going to do is I'm going to fire up my Jupyter Notebook using my terminal. So I have my terminal here. So I'm going to launch my Jupyter Notebook by typing Jupyter Notebook. Okay, first cd into the directory of your choice that you want to save your notebook. For me, I have a directory I'm going to save my notebook to. So I'm going to cd into that, cd this to document, YouTube project, cd Python, cd Cosine, similarity. So I'm going to print working directory. Now, fine. So I'm in my project directory. Then I can launch my Jupyter Notebook by typing Jupyter Notebook. This should fire up my notebook in a browser. Fine. So what I'm going to do now is I'm going to create a new notebook. So I'm going to press new Python 3. So fine, I have this there. So I'm going to rename my notebook to Cosine Similarity. And this name is an intuitive name. Should be easy, straightforward. So by pressing rename, I've renamed my notebook. Yeah. Let me explain what we are trying to do here. We are trying to get the similarity between two vectors, two documents, two strings, two articles, two images. How do we go about that? First of all, computers don't understand letters. What they understand is number. Computer only understand numbers. So whatever format we are trying to get the similarity of, we need to convert them into numbers. Whatever data format we are bringing, we need to convert them into numbers. So what we are going to be doing in this tutorial is that we want to get the similarity between two documents, two articles. So we'll be copying some articles, then getting the similarity between them. Also, like I said earlier, we can get similarity between two numbers. For example, we want to get the similarities between this sentence 1 is equal to the economy is growing and business is yielding more profit. Sentence 2 is equal to the country is in a state of progress whereby citizens commend the government for improving the economy. So What if I ask you to calculate the similarity between these two sentences? How do we go about it? So I'm going to be showing you how we go about this. First, we need to convert these two strings into numbers. Because like I said earlier, computer don't understand strings or articles. What computer understand is only numbers. So we are going to build a function that converts these strings to number of vectors. So build a vector where each string is converted to a number, and it will be some sort of a binarized vector whereby we have what we'll be getting at the end should be something like this: 0, 1, 0, 0, 1, 1, 1 at the end for each sentence, because each sentence will be converted to a vector. This is what we'll be getting for sentence 1. Something similar for sentence 2, based on what we'll be building now. Now, let's insert a new cell above. As a new cell above. So like I said earlier, we need to create a function that converts our sentence to vector. Vector containing binaries. So we'll name the functions. We can name anything we want, but we want this video tutorial to be as intuitive as enough. So call the name of the method def build sentence vector. This will take into parameters. The first parameter will be the sentence 1. Sentence 1. The second one will be sentence 2. Now we need to convert our sentence, which is a string, to a list. So we need each of our sentences to be iteratable. So how do we go about that? Since all the sentences are demarcated with a space, so we need to split them based on that. So how do we go about that? I will create an iteratable 1, which is equal to sentence 1 the split. So by splitting this, our sentence 1 will turn to a list as against the string itself. So we'll do the same thing for sentence 2, which is equal to sentence 2 the split. Now we have a list of our two sentences passed as a parameter to our build sentence vector. We have them as a list. If you check the data format for this will turn to a list by splitting the sentence coming from the parameter. Then what we will do now is we need to import the counter class and the math class, because we'll be doing some calculations, and also we'll be counting the number of times a word appears in a sentence. We need to build something like a bag of words whereby we merge all the letters. We merge all the words in our sentence, our two sentences. Then start picking out how many sentences in that bag of words appear in sentence 1. That is how we create our vectors. So I'm going to import the math class. I'm going to import the counter class also. But before, how do I import the counter class? I will need to import the package called collections. So from the collection package, I will import the counter class. So from collections, import counter. Remember capital letter C for our counter. So what I'm going to do is I'm going to add new cell below. I'm going to run this. I'm going to run this also. So for our sentence one, I'll create a counter which looks like something like this. Counter 1 is equal to counter iterable 1. Iterable 1. Counter 2 is equal to counter iterable 2. Now, to check if you prefer to know what is happening underneath, let me use this medium to tell you or to show you what is happening underneath by printing each variable. So what I'm going to do now is I am going to be printing the result of all these variables I'm declaring. So let me do that now. I'm going to run this function, build sentence vector, build sentence vector, and show you what is happening behind the scene. Sentence 1, sentence 2. So let me print this. Print iterable 1 and also print iterable 2. So by running this, we are good, no error. I'm going to run this also, no error. So let me run this. Fine. So as you can see, our strings or our article is broken down into tokens, which is a list also. So by splitting each sentence passed as a parameter, the article is broken down into list, and the list is iterable. So this is the result of that, and this is for sentence 1, sentence 2, as you can see. Now let's move on. Let's print the content of counter 1 and counter 2. So we'll see how we are making progress. Run, no error. I'm going to run this. We are cool. I'm going to run these functions also. So as you can see, is appeared twice in the first sentence, D appear once, economy appear once, growing appear once, and others. The same thing applicable to sentence 2. D appear twice. Here we have D appear twice. We have D here, and we have D here. They appear twice. We have D here. We have D here appear twice. Also, we have country which appear once, is once, state once, progress once, and all of that. Normally, if you want to do something of this, you will need to preprocess your article before sending the article into the sentence vector, whereby you need to typecast it by converting your article to a lowercase. Also, if you want to remove stop words such as is, are, some stuff like that, because they don't really add to your result. But for the case of this tutorial, I would just want to pass it like that. But if you are building something great or something bigger than this, I think you should check out preprocessing text before passing them to your model. So for this, let's move on. Now, I will need to merge the two dictionaries together to create some sort of the bag of all features like I told you guys earlier. So the way we are going to do that is we will make use of the set. We'll make use of the set function in the Python. And also, if you remember, in Python, in set is a mathematical model for getting elements that are of the same type, elements that are not, so and some sort of stuff like that. So in set, remember, you can do something like a union, you can do intersection, and other. So now we'll be making use of the union class to get we'll be making use of the union class to merge the two tokens inside each sentence together. So now the full data should contain unique tokens from the two sentences. I think I'm making sense. Now we'll do something like all item or all tokens is equal to set. Remember I told you we're making use of the set function. Counter one dot keys. Why are we doing this? Because we need the key. This is the key, the value. We are not concerned about the value of how many times each word appears. We are concerned about the key. We have is the key, D is the key, economy is the key, growing is the key. So counter one dot keys. Remember, we are merging. So we'll be making use of the union method. Also set counter two dot keys. So what we did is we try to we are merging the keys, all the keys from sentence 1 to sentence 2. With this, we are supposed to get, or we'll be getting a unique tokens from the two sentences. Now, to show you what is happening underneath, I'm going to print this out. I'm going to print all tokens to see if we don't have error. Cool, we are cool. Yeah, as you can see, growing is from the first sentence, D, whereby, this from the first and second sentence, so you see one of it. Whereby is from the second sentence, which is this. Country is from the second sentence. So you can't see repetitive tokens in the final all tokens variable. What you'll be seeing is unique value from the two sentences. Good, we are making progress. Now we need to create the vectors. This is the final part of the build sentence vector functions. We need to create each vectors from the sentence. So how are we going to do that? We'll create a vector variable, vector 1, which is equal to, then we need to iterate all our sentence in each sentence on the all tokens variable. I don't know if I'm making sense, but I'll practicalize it to you and so you see how it works. So I'm going to do something like counter 1, which is k, for k in all tokens. So what we are doing is we are counting how many times a token in sentence 1 appears in all tokens. So we are picking Do we have D in this? How many times? Yes. Do we have economy? Yes. Do we have is here? Do we have growing here? So you have, at the end, you have something like this, 0, 1, 0, 1, 0, 0, 0. I'll print it out for you so you see. So the same thing applies to our vector 2. So what I will do is I will copy this. Then I will change vector 2, counter 2. So if you are still confused about this, I'm going to print vector 1, vector 2. So let's rerun this to know if we're on the right path, no errors. Cool. So we have errors. All token is not defined. So we have all tokens, not all token. Guys, sorry, my bad. So let's rerun this. Cool, we are doing great. So like I said earlier, we have something like a one-hot encoding that shows if each tokens in a sentence appeared in the all tokens variable. So like I said earlier, we have 1, 0. So this is D appear in all tokens, 1. Economy appears 1. So if you check, the length of all tokens is equal to the length of this. So these are the unique values between these two sentences. So if I count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. So the total unique values from the two tokens are 22 iteratable tokens. So then we now count how many times our tokens from each sentence appear in all tokens. I think that makes sense. So what we are going to do now is we are going to return vector 1 and vector 2. We are done with this function. We are done with the method that build our sentence vector. So what we are going to do is move on to the cosine similarity functions. So that is the mathematical behind we are going to write the mathematical behind the algorithm. Remember, the build sentence vector we did is just to convert our article to numbers. So what I'm going to do is I'm going to create a new cell below, so to give space. Yeah. Now, so I'm going to call our method cosine similarity, and it's going to take two parameters, which are vector 1 and vector 2. So the def cosine similarity. So we take in vector 1, and vector 2. So what we are going to do is, I will show you what we are going to do, and we'll write the first part of the formula, which is this. Then write the second part, which is this. So the first part is the dot product, A dot B. So let's write the first part. So I'm going to create a variable called dot product, which takes the sum of n1 times n2. And what is our n1 and n2? Our n1 and n2 is, we are iterating all the elements in our vectors, in our two vectors passed as a parameter. So I will do n2 here in zip. Remember, we are taking the two elements from our vector 1 and vector 2 at the same time. That is why we are using zip. Zip, you pass a vector or a list to a zip, you iterate over the zip, you get all the elements in the same position of the list passed as a parameter. So that's the beauty of the list function. So we are done with the dot product. So remember, we can run this to see if we don't have any error. Cool. So now let's write the program for these two. We have the first one and the second one. So what we are going to do is we are going to write, I'll call it magnitude 1. Magnitude 1 is equal to math the square root. Remember, we are using the square root function, so I will do math dot square root of the sum of n is to power 2, and what is our n? Our n is the iteratable values of all the elements in our vector 1. Hope I'm making sense. Same things applicable to our magnitude 2, which is the square root of the sum of n power 2 for n in vector 2. So what we've done is we've done this, and we've done this. So this, the dot product, the formula is the same thing as the dot product of A times B, and divided by the square root of this times this. So for my Python program, I'm going to return the dot product divided by bracket magnitude 1 multiplied by magnitude 2. So I'm going to run this to see if we're on the same page. Cool. We're on the same page. Now, to run the our program is ready. We have the build sentence vector that convert our strings into vectors. Then we have our cosine similarity functions that takes in two vectors and also output the similarity between them. So what we are going to do is we are going to supply our sentence TDO code, so we'll get our values, our similarity values back. So here I'm going to create the vector 1 and vector 2 from the build sentence vector, since it returns two values. So I'm going to do this, vector 1, vector 2. So non-time, object is not iterable. So, okay, let me rerun them. Rerun. Oh, I think I supplied vector 1 and vector 2. So let me change these to vector 1, vector 2. So I'm going to run. Fine. We're almost there, guys. Now we have our vector 1 and vector 2. I can print it out if you want, or you can print it out if you want, or you can just move on. We need to pass these two vectors into the similarity function. So I'll create another variable called similarity, which is equal to the cosine similarity method to take in vector 1, comma, vector 2. Now if I run this, everything works fine. So we can print our similarity results and see what we got from it. So our similarity is 0.26. The similarity between these two sentences is 0.26. Wow, interesting. Also, we can also get the degree at which both sentences are similar. So how do we do that? Let's create. First of all, we need to get the angle in radians. Then how do we do that? We create a variable called angle in radian, which is equal to math cos. Then supply our similarity. So let's run this. Fine. Then we need to create another variable, which is degree variable. Then we'll use the math.degree class to take the math.degrees to take in angle in radian variable. Now everything works fine, so we need to print the degree at which both values are similar. We need to print the degree of the similarity between the two sentences. That's what I mean by that. So I'm going to run this. So the degree is 74 degree. Remember from our slides, to get the degree is scores vector are nearby orthogonal. So scores vector are nearly orthogonal angle between them. So our scores is 74 degree, which is close to a 90 degree. So they are unrelated based on the slides that I prepared. They are unrelated. Now let's compare this with notice these scores, because we are going to compare it with some article bigger than this. So what I'm going to do is I'm going to copy this, then copy this. So I will call this similarity. I will call this degree. Now let's check the similarity between. Let's go online, Google. Let's check Marvel versus DC. We'll do Marvel Comics Wikipedia. So we'll copy the whole of this. Copy the whole of this. Let's move back to this. So sentence 1, this. So for us to be sure, I will make everything into one line. Fine. So the same thing applicable to DC Comics universe. So DC Comics Wikipedia. So I'm going to create this also. So I'm going to copy the whole of this. to C, going to paste that here. So I will need to remove double quotes from this, to avoid any errors that we'll be getting. So I'm going to convert all this into a single line. And let me just remove this. You can pre-process your sentence or your articles before passing them into this. It doesn't matter. So I'm just doing this to show you how it works. Now everything looks fine. We should be able to run this. Everything looks fine. This. Interesting. We got the similarity of 0.6 and the degrees 551. So our similarity works well when we have a large article from what we've seen so far. And if you can see the degrees turning towards 0 as against 90. And for results turning to 0 degree means they are of similar scores, means both articles are slightly related. So if I continue to pump more articles to this and the degrees start coming down to 0 as against going up to 90, it means the two documents are similar. So guys, I think we've come to the end of the video tutorial. If you have any questions, comments, reviews of this video tutorial, feel free to ask me on the comment sections, and don't forget to like, subscribe to my video channel. I will be glad and happy to answer your questions. Thank you guys.